So I've had the notification of the tool that I am live. I hope this is the case. If I could have a thumbs up or anything that would show me that you can hear me, that you can see me, would be I see them. Awesome. Perfect. Perfect. So I will go slow because it is summer. So I will give some of our colleagues a couple of more seconds to join. While I'm doing this, welcome everyone. I'm very happy that you've taken the time to join the webinar, even if it's summer and it is already holiday season for a lot of us. So I'm very happy that you still take the time to join me and to listen to me. My name is Klaus Dafinger. I am part of the marketing team for Legrand Data Center Solutions for Europe. It was not always like this. So I'm in data center business since 21 years now. I've started there as an installer, planner, consultant. Now I joined the marketing team, so I spent countless nights in data centers and around data centers over the last 21 years, which I'm very happy about. So because I did a very long journey actually, and there is a lot of changes that I've lived with and was with our clients and customers to do this over the past 21 years. And this is also one of the reasons why I thought, or why we thought, this might be an interesting topic for all of you. So that's the reason why we set this webinar, which is the last one of the series for this summer. And this is about a new influence, a very strong influence, or potentially a strong influence on a data center, which is the OCP topic. So that's the reason why, because in my eyes and in many of our customers' eyes, this is something that they have heard, may never have heard of, but it is definitely worth into exploring it a little bit. So let's start right away. So strategies for modern data centers, so OCP, is it the future of a modern data center or not? In order to understand this a little bit better, we will also explore, so what is OCP overall? So what does it mean? What is it? Why is there a group of people, a big group of people talking about OCP? Why is AI accelerating this? So what is the impact on AI, specifically on OCP? What is that we can expect as changes in a data center caused by OCP? And then I guess a very interesting question for everyone. So will it affect my business? So do I need to prepare for it? What is it? What can I expect? What do I have to expect from OCP? And finally, as I said, so if I expect this, how can I prepare for it? And what is it that I could do or that I should do? In order to start this, for me, it is always very interesting to know, at least it's very interesting for me, if you have heard of it or not. So I have a quick audience poll. So a question and a couple of multiple choice answers. So if you could just hit the button. So how familiar are you with OCP? So have you heard of it? It is completely new to you. So just that I have an idea and a little bit better of understanding where we are. And yeah, oh, very familiar. Okay, we have some of them. Majority of it, yeah. Okay, I've heard about it, but I don't know the details. Completely new to me. Absolutely, yes. So the pool is opened a few seconds more. So take your time, but the result so far is not very surprising to me. That's actually quite normal. Whenever I have the chance to talk to an audience, I just for my knowledge, I ask the same question, and the result, it's not very surprising for me. And you should see the results now. I guess so. And as you can see, so majority of you is that you have heard about it, you have heard the name, the term, you don't know really where to put it in. For some of you, it is completely new, and then a few, very little of you are very familiar with it and they already use it. Very awesome, and then somewhat familiar. So majority of it, 70% plus, have heard of it or are totally new, which is absolutely normal. So that is absolutely normal. And having this said, this is exactly what we also will cover during the next minutes in the webinar. So we will look into it. What is it? What is OCP? What does it mean? So why is there something like OCP? So, and why is the topic and the speaking around OCP gaining attraction at the moment? Again, it is one of the biggest drivers at the moment who is really pushing the speed, pushing the limits, is AI and the change that comes within AI. So the left side, this is like the traditional enterprise environments. The workloads are distributed across many individual servers. Most of it is CPU based. The density per cabinet is moderate. So in the past, let's go 5, 6, maybe 10 years back, we were at 3 kilowatt, maybe 10 kilowatt, and as an average. So there were always tops and there were lower ones, but as an average in all data center from enterprise to hyperscale, the average load was between 3 to 10. Now we're talking about more as an average of 10 to 20 kilowatt per cabinet. The traffic, so the communication, was also predominantly within the cabinet or north to south traffic. So there was not that much meshed network used in the past. And it was also more predictable what the infrastructure needs. So the steps, and when there was an expansion, was more predictable. It was just in a lower scale. If you look at AI compute now, so we have more and more GPU clusters communicating or built within a very limited space, a very dense environment within the cabinets. We see real spikes in the density, in the loads of cabinets. So an AI installation has typically or easily 100 kW plus per cabinet. The communication between those cabinets is also like in a meshed communication network. So it goes in any direction. So everything goes the fastest route or is even splitted on those. And also the infrastructure needs are increasing rapidly. And by infrastructure, I'm not only talking about really the network and the communication part of it, the communication connectivity between those. It is also the power demands that increasing drastically, the same as it is for the cooling. So we have on one side the driver of this. The driver is AI workloads, the increased rack density, the power demand, and the cooling that comes within. The impact on that is that the GPU clusters increasingly replace traditional CPU infrastructure. We have the density increase. On the power demand, we even have new power distribution architectures, and for cooling, also change and a trend towards new cooling technologies, which is not like in the past only air cooling, which is an hybrid cooling, hybrid and liquid cooling becomes more and more strategic. So, and those are the trends that changing the requirements of your infrastructure in data center, and those conditions, and this is accelerating the OCP adoption. So Why is traditional data center being challenged? I mean, we have the 4 points, the 4 big points. So AI is not simply adding more compute capacity to existing data centers, it's changing the entire infrastructure around the computing cabinets. So high power densities require new electrical architectures, increased heat loads require or drive new cooling approaches. So the CPU clusters demand more connectivity as traditional enterprise workloads ever had. And that spikes in the 4 main points that are being challenged if we compare traditional data center to the needs of now. More power results in more heat. We need more connectivity and more integration, meaning we need to be more flexible in when we expand, when there is something new, something additional coming into my data center. So that is an important fact. So the infrastructure is evolving to support AI, not the other way around. Having all of this said, we understood, so what is it, what causes it that I need, or the drivers and the impacts of those, and why is it bringing in or accelerating the OCP. Having this said, we will now look at the first time I will really give it to you. So what is it that OCP? So why is it accelerated? Why is it gaining more attraction and everything? So OCP is short for the Open Compute Project, which is everything but new. So OCP and the community was founded in 2011 by Facebook. So in terms of data center, this is ages ago. So it is not new, the topic itself. It gains traction and importance now with also the impact of AI. So that's why it gains more and more traction of this. So originally founded back in 2011, it was and still is. It is an open source community that is creating scalable, flexible, and energy efficient solution for data centers. So the idea of OCP was and still is to share ideas, to share engineering, to reshape and define a possible new architecture for data centers. Always with the focus of it being more flexible, it being more energy efficient, it being at one point easier available or quicker available, since it is a shared platform independent of the manufacturer, and everything works together within the community. So founded in 2011, meanwhile, the community is grown huge. So every data center player that you might have heard of is contributing at one point to at one or another point into the community, by contributing with new topics, contributing with new challenges, or contributing with the solutions being built in, being discussed within this community, and then at one point being the state of the art within the OCP at the moment. So it is a huge community that has been built, that has been started decades ago, actually. So as said, in 2011, OCP begins. So that was the launch of the first Open Compute project. The focus back then was more on servers and data center hardware. So the focus back then was with the start to redefine or look into the server and the hardware. In a later step, it expanded beyond the server, because it starts at one point, but then obviously this affects other pieces in the puzzle of a full data center. So it starts at one point, and then if we change this has an effect on this here and there. So it expanded it, and it included then storage, networking, racks, and power. So this is where also contributors outside of server manufacturers were within this community and worked together to face the ideas and the challenges being developed within this community. Further down the line, I mean, it growed bigger and bigger. So the ecosystem, the vendors and the solution providers, so more and more people connecting, more and more people working together. By starting from 2020 to 23, the focus started more and more on the rack level architecture. So from this starting point, with the impact of the servers on the rack level architecture, so the cabinet itself, the power distribution within the cabinet, and also how to deal with the high density commuting power driven by AI. So how to deal with this in an efficient way in terms of energy usage, but not only energy usage, also how can we, for example, cool this in an efficient way, and also in a way that it works, because in a modern high performance compute server, traditional air cooling, for example, is not enough anymore. So the OCP community has taken all those considerations, all those input, and they were working together on bringing solutions. And yeah, starting from recently to today and the future, I mean, the AI accelerates the relevance of those, because if we look at the development of the big AI companies, the big chip manufacturers and everything, so there is so much going on in a very, very short period of time. So that's why this has given a real boost to it. So that's the OCP and the history. If you look at the OCP working groups, so within the OCP community, there are working groups. There are working groups that look at the sustainability part of it, security, cooling environments, storage. So every part of a data center connected has a single working group where the specialists are working together and focusing on those topics to develop it to the next step. There are some things that have a physical impact on a data center, and this is one of the biggest challenges for data center users. And that is obviously the working group of the data center facility, cooling environments, server, rack, and power, because these are the things that you being confronted with new equipment, with new challenges. And that's why this is one of the most relevant topic for data center users, data center managers, data center builders, which is the physical aspect of this. And this is the main thing that we're focusing on, because there are new technologies evolving and new, in easy words, new pieces of equipment falling out that are being used or that can be used within your data centers. The principles behind the OCP is, even if it covers many different technologies, they're all guided by the common philosophy of it. So the first principle is standardization. So mechanical and electrical interface that make it easier for the equipment from different vendors to work together and simplify large-scale deployments. So that by standardization, which is like everything should be kind of the same technology, that it works seamlessly together, no matter who sourced it or where you have bought it from. So that is one very important topic of the OCP. The second principle is modularity. Rather than treating infrastructure as a large system, and individual components can be deployed, maintained, or upgraded independently. So that increases the flexibility while reducing operational complexity. Scalability and modularity is very, very important for this, modularity is one of the key components of this community, obviously, because modularity and flexibility is what keeps your data center state of the art and also ready for everything that comes in the future. So that is one of the key pillars of all of those working groups. Scalability, the next one. So modern infrastructure needs to grow efficiently with the increasing demand, particularly when AI hits the data center, because there's normally that when AI environments, so they can very quickly change the requirements, and that is something that you want to be ready for. Efficiency, on the other hand, is the same as important. So removing unnecessary complexity, reducing power conversations, so reducing loss, simplifying the infrastructure, all in all to contribute to lower operational cost and improved sustainability is obviously a very important topic. It not only saves you money, it also saves the environment. So a very, very important topic on this. And finally, which is very, very important, I mean, it's part of the name, it is open. So openness is the defining characteristic of OCP. So openly sharing the specifications and encouraging collaboration, innovation happens much faster than it is before. So that's, I think, I mean, that's also by definition in the name of the Open Compute Project. So this is sharing the challenges, sharing the solutions, sharing the specifications, and really collaborating and working together to move this as fast as possible and to move this in the best direction. So this is what the OCP is about. So we have a first idea of OCP. We know that it is going to impact every part of our data center. We know it's going to influence a lot areas within the data centers, and that's if you are familiar with it or not. I have a second question. This is also just to check if you're still awake or not. So what areas do you believe, if you know it or not, you can also take a safe guess, absolutely fine. So which area do you believe OCP will influence the most over the coming years? Okay, halfway in. Yeah, that is interesting to see. So still a few seconds left. There is not a clear winner, which is also not very surprising to see. So we will share, it is closed soon, and then you should be able to see the results. So there is not a clear winner. So it was power distribution, cooling infrastructure, overall data center design, which are closer to each other, and the rack architecture on the last place, which is, as said, it is not surprising to see. It also depends a little bit on the view that or on your day-to-day work within the data centers. But yes, so what you have voted is exactly what the OCP community and the OCP will affect the most. So overall data center design, yes, absolutely, but also the power and the cooling. But very interesting to see that this is absolutely also what you expect to happen. So to the poll, we had, I think it was 5% that says it has the most impact on rack. Well, it impacts the rack, but the OCP is way more than just a cabinet. So if people hear OCP, and normally the first thing they see and the first thing that is visually for them, or that is even presented, because it is yeah, very much visible because they are big, is cabinet. But as we already seen, that OCP is much more than that. So that diagram sees that what is the accelerators, what is the effect. So we have the CPU, GPU accelerators, which has an impact on the IT hardware, server, storage, networking, which being changed or reviewed in terms of higher computing density, higher needs, higher density, new cooling technologies, which has then an impact on the rack architecture. So there is a new type of a new rack architecture approaching within the OCP, and this also has effects driven from the IT hardware on the power side and the cooling side. And this obviously, so if you touch the power and the cooling distribution in your full data center, so that affects the data center facility overall. So this shows basically exactly how you voted in it, which is very, very nice to see. So having this heard, so what is it that is gaining momentum? So one of it is that I moved infrastructure decisions to rack level. So the cabinet is increasingly becoming a system. So it contains compute, power, cooling, networking, and the mechanical design needs to hold all of those together. Large AI platforms increasingly define the infrastructure requirements. So the GPU platform roadmaps have direct consequences for rack architecture, power delivery, and cooling. When I say AI platforms or AI developments and the big chip designers and everything, I am very well aware that not everyone has or will have a huge or a minor or even an AI installation at all in his data center. Absolutely, or maybe not in the near future, but in the future. But true is also that the technology is driven by them. So if there is a new AI platform being developed, a new set of chips with new demands of power and cooling, the technology follows this trend, and it will be then available for any other system within a couple of years. So even if you don't have big AI deployments in the near future, small AI deployments, not at the moment, not planned, the influence of the technology will become the new normal for even smaller deployments of standard systems. So just that you keep this in mind. We are very well aware that not everyone has or needs a huge AI installation. The third one is why OCP is gaining momentum is that liquid cooling has moved from niche to strategic. So the move towards direct-to-chip and hybrid cooling creates an opportunity to rethink your complete rack rather than simply adapting existing designs. So that is for the approach, which we will see later. So what is it that I should think of to be ready for if I may have an OCP deployment or an OCP-inspired deployment in the near future? So AI and OCP focused on the cooling technologies to deal with the higher workloads. And finally, so the gap between hyperscaler and the wider market is narrowing because of this. So the technologies and the architectures developed for hyperscale, high density environments are increasingly relevant. So and have also an impact on HPC or parts of the enterprise infrastructure. So that's what I said. So on one side, we have the drivers, we have the big players who really forcing it and bringing the technology up. And then on the other hand, we have the users of those. So how are they influencing it? I mean, that's essentially what I said, and I'm pretty sure that all of you are aware with this gentleman that you see on the top left picture and his company. So those he and his colleagues are predominantly the one who are influencing the entire industry by developing the new architecture, presenting the new chipsets, the new power demands, and at the same time also giving the reference design to run this equipment the best, the most efficient, and share it with the world. So this is the influence of the hyperscaler influencing the entire industry. And even if you do not, even if you will not have an NVL 72 or a Grace Hopper, whatever chipset it is, the influence and the drive of technology has an impact on everyone. So, I mean, that's totally how the innovation spreads. So it is starting at the hyperscalers, at the big ones, then followed by the early adopters, so which is AI, HPC, large cloud, colocation, enterprise, and at one point it becomes mainstream in the data center design. Even if the density is a different case, so even if there is no deployment of 100, 200 kW cabinets, nevertheless, the technology influenced by those high density installation waves down and becomes at one point the new normal for your data centers. So what does it mean for data centers? So we have, again, the four key pillars. That is something that is influenced that we look at. So power, this is a question that you have to ask yourself. So can my power architecture support significantly higher rack densities? Because they will hit the data center at one point. And significantly higher does not mean 10 to 100 kW, absolutely not. Significantly higher on a lower scale means also double the density. So could you support in your data center double the density? So if you have now an average of 10, can you and your power architecture support 20 kW per cabinet? So it's just 10 kW per cabinet more, but in a full data center, it is 100% higher demand. So even this is, it's not always the step from 0 to 100. It could be also in between, and then on top of it, being ready for what is after the 20 kW. So that's the main challenge. The same for cooling. So can I introduce liquid or hybrid cooling when required? Very important part. So for new systems for the future, you have an existing data center, it's running good. If you have to change your systems, it will not happen overnight. It will not be 100% of your servers. So no one will wake up on a Monday and say, oh, I have a great idea. Let's scrap our full data centers and bring in new servers. That will not happen. It will be a growing part of it. So is your cooling infrastructure ready to do this? Can my cabinets, can my physical infrastructure, so can I place new equipment in that? And by new equipment, it's not only that the equipment itself is OCP, it means also are my cabinets size-wise capable of, so first of all, can they take the load of the cabinet of heavy equipment? And secondly, is the density and the size of the cabinets supporting, for example, liquid cooling? You need more space in those. You have the manifolds in the back, you have the piping. So all of those things, and then flexibility as the key. So I am fine for now. I may be fine for the step of, I used the example of 10 to 20 kilowatt. Am I also ready for the step to 40, 50 kilowatt or whatever? So that's the key pillars to think about. Coming back to OCP, what the impact is and what the questions are that you should ask yourself, you could ask yourself, and that also the OCP community had asked themselves before. So this is what they what the OCP influence, what the OCP is, what the OCP changes are on the rack architecture. So once that we see, so we have on the equipment space, so the equipment is getting bigger. The servers, this has several reasons. This is for manufacturing, this is for easiness, this is for have them a little bit cheaper, and also to make the same time space for direct to chip and the piping within the servers that is needed. Then the power distribution of OCP is done with an 48-volt DC vertical bus bar, which you can see in this illustration on the cabinet on the back, which is running centrally over the full height. So this is the back of the cabinet, centrally running over the full height of the cabinet, which distributes the power. We will have a closer look at it on the next slides. The same as for the blind made power connectivity interface. So we will have a closer look at that. And on the how the power is distributed within. So looking at the cabinet itself, so what is actually the change from a standard cabinet that we are used to use to an OCP cabinet? So a traditional 19-inch cabinet, we have to change from 19-inch equipment to 21-inch. So it's getting wider. The equipment has and needs more space. The rack units are used the O units, so an open 48 millimeters instead of 44, so a little bit more in the height. So overall the dimension is slightly increasing of the equipment. And then also the equipment supporting the cabinet is designed around the open cabinet mechanical architecture, so to support this and the wider and the bigger hardware that goes in. On traditional racks, we also have a huge ecosystem of standard 19-inch IT equipment. For OCP, the equipment requires to be designed for adaptation for the open rack. The traditional 19-inch cabinet is like familiar cabinet-based architecture. I mean, everyone knows a server cabinet for his data centers. And the OCP is more like a system-oriented rack architecture. So it not only supports to bring in the equipment, the step further thought of the cabinet is also how can we deal with the power distribution also for high density environments? How can we deal with the cooling? So also where to bring in the cables, where to exit the cables, because like the very high connectivity required of those. So this is a system-oriented rack architecture to serve all purposes built on the platform, the cabinet itself. On the second level, which is the power distribution made within the OCP community. So this is also something that was rethought within the OCP community. So traditionally, every server is connected to an PDU or to whatever power distribution device that you have been using with two power cords, so A and B on AC, 230 volt AC. The bus bar, the PDU was connected to a wire cable or a busway with using tap-off. So that was it, how it was traditionally being done. And the power conversion, because the chipsets and everything in the server so far is running on 48 volt DC or 24 volt, depending. So the power conversion was done in each system themselves. This is also something that the OCP community worked on, and the servers manufacturers as well. So the power conversion was done decentrally in the past. Now the power conversion is done centralized. So in every OCP environment, in every OCP community, OCP cabinet, there is a power shelf that needs to be placed inside. The power shelf does the conversion from AC to DC on a central space. So if we follow the blue dotted line, this connects to the busway to AC power through 400 volt Y delta on wherever part of the world you are. It doesn't matter. And then this transforms the power from AC to DC. And then it comes out at the violet dotted line, and this is the output, and that connects to the bus bar which is installed in the OCP cabinet. And then this distributes to each of the cabinets, of the heights of the cabinets, so that the power can be reused or can be used then by the servers itself. This is what one of the power shelves look like. So there are different options available. The density, so you can have 1U or 2U of those. They can support 18 kW or 33 kW output of those. So there are PSUs in it, so which are doing actually the transition from AC, the conversion from AC to DC. So on the left picture, you see the front of those with the PSUs. On the back, on the right-hand picture, you see the blue connectivity point. So this is the power input, the AC. And then at the very back of the cabinet, you see that the housing of the cabinet and the connectivity point is pointing out. This is the output of the 48 volt DC, and this is the thing that connects to the bus bar in the cabinet and distributes the power of 48 volt DC. If you need in your cabinet more than 33 kW, which most likely can be the case, then you can place several of those. So you just place a second one of the power shelves, and then your cabinet can go up to 66 kW. There is one important point that you have to be aware of. It's not fully on your own wish how much power, so you can't stack 10 of those and then you are good for 300 kilowatt. No, that's not how it works. There's the physics behind that a little bit. So the bus bar at the back of the cabinet needs to match, obviously, the power distributed by the power shelves. So obviously, the more power you have, the more copper you need at one point, that you can maintain the power of this. For DC, the power is the currency times the amperage. So the currency with 48 volt DC is the fixum. So if you stack more of those, you increase drastically the amperage, the power sourced or drawn by your system. So that's why the bus bar in the back needs to match the overall load of the cabinet. So you need two things. You need one or several of the power shelves and the matching bus bar that you are safe to support the amperage. There is a physical limit behind that, but every distributor, every vendor can support you with this, just that you need to be aware of. The blind mate connection, and this is something that is very awesome. So every piece of equipment that you install in an OCP cabinet, you push it in, it connects automatically to the bus bar. The same for the server, so there is no need for a second look. That's on the power part. For the cooling, this is what I touched earlier, what I said. So with the increase of the servers of GPU clusters with the higher power demand, there is also higher density, higher cooling needed on a very dense spot. So important is not only the full load of the cabinet, very important in these times is also the heat flux, meaning the heat that is occurring on a very dense spot, which needs a special type of cooling because air does no longer do the job to cool those properly down. So that's why a hybrid cooling approach is needed for liquid cooling, for those high density, for those high dense spots, and air cooling for either legacy equipment or things that have not a heat plate and heat sink installed. So basically everything else than GPUs and servers. Having this said, and had given you an overview of this is the physical impact at first that will occur. So we have the cabinet, we have the power and the cooling. I have another poll which is very interesting for me to see. So do you expect to have AI workloads in your organization either increasing in the near future? They already have increased significantly, or you don't expect this at all to happen? Yeah. Okay. So we are halfway in, and that is very good to see. One thing which is not surprising, I mean the one with the lowest votes, 0 actually, should not be surprising, which is decrease, because no one is expecting to decrease the load or AI workloads. And then some of you, so over half of you, already experienced or expect a significant increase of those. So more than 80% of you expect a moderate or a significantly increase of the AI workloads. Whether this being dealt with OCP or not, you will see elements made by the OCP community and being picked as the solution for an HPC environment. So thanks for contributing to this. Very, very interesting to see. Yeah, I think we are back for it. So having this said, we've looked at what the OCP looks at the moment. I want to give you also an overview on, so what is the OCP community working on right now? Why may this be interesting for you? Because if you plan a new data center and rebuild and reconstruction in the near future, this is something that you might want to be aware of, that you might want to heard of, because this might impact the way you approach your design for your future data center. So looking at the chipsets, because this is when we think back of where does it start, where's the influence. So if you remember the picture with the waves, when it becomes mainstream. So this is one of the things that we are looking at and that every manufacturer is looking at. So for example, the roadmap of the NVIDIA, so Blackwell Rubin and the Feynman, the Kyber cabinet, which will come at a later state. And all of those with the increased density and for the Kyber cabinet and stuff like this, we're talking about cabinets that have 600 kW in one cabinet, 1 megawatt per cabinet, which is way, way, way beyond the normal. But this drives the technology and is then distributed on a different scale, but distributed for all of the systems. So it's not that they install 1 megawatt, that in 10 years from now, every cabinet in every data center will have 1 megawatt. That would be impossible and also not needed on top of it. But nevertheless, the technology made by this, provided by this, driven by this, will impact the infrastructure of your data center in the future as well on a different scale. So this is why also the rise of sidecars is there. So you may have heard of it eventually, and a higher voltage in new architecture. So traditionally, it was done the computing rack, and then we had the AC PDUs inside, which were running to each of the servers. Today, within the OCP architecture, it's like we've seen. So we have the power shelves connected to AC, distributing, converting to DC, distributing it with the vertical busbar over the full cabinet. This works to a decent level of density. For the moment, the limit is at about 76 kilowatt for physical reasons. When I say at the moment, this will only stay like this for a short period of time, because then the next generation of the bus bars will be there who can deal with a higher amperage. If we look at the demand of how the industry deals with the future of the hyperscalers, then there is a different approach needed, which is sidecar. So you have one cabinet which contains the computing cabinet, so every server, every piece of network equipment, and then you have a cabinet next to a cabinet which is called a sidecar, and the only purpose of this cabinet is to distribute, converse the power and distribute it to the server, that you can achieve this high density. On a second level, there is also an increase in the voltage expected. So not only 48 volt DC, we're talking about higher voltage, probably 400, even up to 800 volt DC distribution to reach the higher demand of the network equipment. If it would stay at 48 volt DC, you would need more copper than actual server equipment within your cabinet, because if the voltage is fixed, the power demand is increasing. The only way it can keep up is with higher amperage, and that would result in you would need a crazy amount of copper within a data center that can keep up and doesn't melt when you would distribute this high of amperage. So the natural next step is increase the voltage, so bring it up to 400 or 800 volt DC, so that you can distribute the power and not have to go very crazy in the amperage, so that also the bus can keep up with that. So that's one of the new things that is being worked on for really high power and high demand cabinets. The sidecar originally is being developed for 1 megawatt cabinet. So don't expect power sidecars to be the need in every data center in the future. Absolutely not. This is how the OCP community at the moment deals with it. As said, I don't think that majority of data center users will have sidecars in their cabinet. Nevertheless, with this step is the new power architecture and probably the higher voltage introduced. So the chips and servers running instead of 48 volt DC on 400 or 800, and this is what you expect to see in your future data center. So maybe not the power sidecar, because you will not have a 600 kilowatt 1 megawatt cabinet at all, but the chip manufacturers, the servers in the future being developed to support 400 volt DC or 800 volt, and this is what you can expect in a future data center on a different scale. So not the crazy high density per cabinet, but the technology developed to support this high density on another level in your future data center. So that's why it is, for me, very important also to show you what is the community working on. So what is it that you can expect for your future data center? And then obviously, I mean, the rise of sidecars, the higher voltage, the future step of this might result in a full high voltage DC distribution inside the data centers. So no need for sidecars anymore, because the high voltage, sorry, when I talk high voltage, I know I'm electrician itself, high voltage is everything else than 400 or 800 volt DC, but in terms of data centers, we talk about high voltage in that, because compared to 12 or 24 volt, it is the next step. So please, if you're an electrician, just ignore it. But in these terms, in the data center world, we talk about high voltage. So a high voltage 400 or 800 volt DC distribution in your full data center that you use for your equipment. The potential benefits of this is reduced conversion stages. So if it's centrally, the conversion is made centrally, you have lower loss, you have lower equipment within the data center, which requires less cooling. So all of those snowballing there. A simplified power architecture, obviously, because if in the future no power sidecars or anything are needed anymore, it is more like, it feels more like natural to use it and more like the way we used to use it. And the design for very high rack densities would be way more easy with those. So we are approaching more the end. So will every data center become OCP? No, absolutely not. So most enterprise data centers, they will continue using normal 19-inch infrastructure for many years. Why? I mean, the existing installed base is enormous. Different workloads have different requirements, and not every application needs OCP scaled architecture. So every data center OCP? No, absolutely not. But, and that's the thing that I try to give to you. So many of those innovations driven and being dealt with within the OCP community are already becoming mainstream. So if you look at the higher rack power, level architectures, the liquid cooling, busway power distribution, open hardware, modular infrastructure, so all of those things being worked within the OCP community are already influencing or existing even in traditional 19-inch. So you can also have a traditional 19-inch with liquid cooling, with direct-to-chip cooling. So technologies driven and made by OCP used in a standard environment. So there is kind of also cherry picking. So what works good? So bottom line, you may eventually never deploy an OCP cabinet, but the next generation of data centers will certainly be influenced by OCP. So things being developed within the OCP community have an effect and visibility even in normal data centers. So when you prepare for the next generation of your infrastructure, we're going back to the 5 questions that we've asked ourselves to come to the future-ready infrastructure design, which isn't defined by one technology, it is defined by flexibility. So if you remember, flexibility, modularity, scalability, that's one of the key elements of the Open Compute project, which are things that you should think of. So what is it that you should do on Monday morning? So if you have to plan for a new data center. So what is the answer to all your questions? So one of the answers for sure is not go and buy OCP, not as replacing your full data centers and do it, but you should think of how can I prepare my infrastructure design today to keep the flexibility for everything that comes tomorrow. So one point obviously is plan for higher rack densities. And by higher rack densities, you might also want to think of building different areas within your data centers. You're obviously, as everyone on this planet, is limited by the amount of power that you can draw from the grid. So if you see the need of, hey, we might expect higher densities because of whatever department in your company, whatever you have an AI deployment, whatever it is, if you plan your data center, there is no need that every cabinet in your data center needs to go up to 50 kilowatt, 100 kW or whatever. So you can also think of areas. So this is your traditional area, and then you have one high density area within your data center. So 10 cabinets, 5 cabinets, whatever it is. And this is the cabinets that you prepare to be ready for HPC for AI, meaning this is the area that you design for the future loads with a higher density and being ready for the power and the cooling flexibility that you have, meaning also liquid cooling ready and all those, so that your piping work is done, that you can have this area or your full data center depending on the need obviously you have and the scope that you're looking at. But this might be also worth something, either rethinking the whole thing or thinking in areas to stay flexible. Always prioritize modularity, so the grow within, so meaning your infrastructure to a certain point being ready and then placing the last pieces, modular design on what the actual need is, because that way you keep your options open. So the goal is not that you build an OCP data center today. The goal is that you build the infrastructure that is ready for everything that comes tomorrow, that comes in 2 or 3 years of that. I guess some of you are familiar with Legrand. We deal with every aspect within the data center: power distribution, racks, cooling, cable management, structure cabling, containment, as well as OCP. I have one last question for today, and then I'm almost done. So if we could start a last poll. So after the webinar, so how likely would you think that OCP concepts will influence your future data center projects? Having this in mind also what I told you. So what is OCP now? What is it for the future? So I hope it was there were some elements in it that may think or may stay in your mind, that may influence the decisions on the future of your data center. We have the questions in, so some of you are still voting. It will close in a few seconds, and then we are almost done. By the way, I'm very happy that you stayed to towards the end with me. You should see my screen by now again. No, it's the poll at the moment. So we are back. So it is the last slide, just as you as the key takeaways. So AI is reshaping the infrastructure. OCP is influencing the industry, even if you will not have it, but it is influenced by it. Flexibility is a key design principle for your future deployments. Infrastructure is becoming more integrated. The impact of one to another technology is very visible, and you build for evolution, not for replacement. Having this said, and with 2 minutes over time, thank you very much for attending today's session. I hope it was interesting for you. I hope you learned something. Please feel free, if you have any further questions or interest, just reach out to me, reach out to our colleagues. We are happy to support you. Having this said, thanks again, and I wish everyone a beautiful day and a beautiful summer. Thank you.